Morning, everybody, students.
Good morning,
Uh,
sir.
Good morning. So we will continue to solve some of the questions related to the that topic anatomy. Okay. Have you practiced any questions at home? As I told you to practice some question on this topic from your practice book. You haven't. Okay. Anyway, so yesterday we did this was the question that I think we did up to here. Is it that the last question we did that conjoined collateral and closed vascular bundles are found in grass stem. Okay. So this was the next question, that is, water containing cavities in vascular bundles are found in. In the vascular bundles, water containing cavity is found. Okay. And that is in the monocot, and particularly it is characteristics of the maize stem. There is in some of the vascular bundles, there is a small cavity due to loss of some of the parenchymal tissue or the protoxylem tissues. Okay, this we can see from here. See this picture, you can see this is the maize stem. All right, major stem anatomy. You can see here lot of vascular bundles are scattered. Vascular bundles are many near the periphery, and towards the center gradually number of vascular bundles decreases, but their size increases. So here is one of the vascular bundles which has been magnified, and in this vascular bundle you can see. mm, You can see here, this is the xylem portion. Can you see here what is written as a metaxylem? And these are the protoxylem. These two. This is metaxylem. Is this portion is the phloem. Okay, this is the phloem portion, and here is a cavity, empty space. You can see it is written here lysogenous cavity. This one is a water cavity in case of mesostem vascular bundles. Okay, and above the vascular bundle, this portion, these are the sclerenchyma bundle sheath. It is just like cap on the upper portion as well as on the lower portion. In some of the monocot vascular bundles, it is vascular bundle is completely surrounded by the sclerenchyma tissue. This is also known as sclerenchymatous cap. So this water containing cavity in the vascular bundle, it is found in maize, that monocot. Okay, so this one is that maize stem. Here we get next question. This heartwood or duramen is. Yesterday already I explained you what is heartwood, what is sapwood. Heartwood and sapwood. Heartwood is also known as duramen, and sapwood is also called alburnum. Okay, Sapwood is alburnum and heartwood is duramen. This is very much durable also. This lasts long, it is not easily decayed, and that's why the heartwood is very useful and it is good for the furnitures and other timber work. So heartwood or duramen is, what is that? It is the inner region of secondary phloem? No. This is the outer region of secondary phloem? No. It is the inner region of the secondary xylem. All right. It is inner region of secondary xylem. Heartwood is inner, and the outer region of secondary xylem is that outer region which is very close to the vascular cambium. This is sapwood. Towards the center it is heartwood and towards periphery it is sapwood. Next is question is more or less similar, that is the youngest secondary xylem occurs where? Youngest secondary xylem, this is also during the secondary growth. Youngest means here the recently formed. Okay, recently formed one. Say if this is the cambium, okay, vascular cambium will produce this side, it will produce the secondary phloem, and this side it will produce secondary xylem. And as the secondary xylems, so those secondary xylem which is near to the vascular cambium, they are the youngest one. Is it? Youngest one is, so new one is produced close to the vascular cambium, and the older one, they will be far away from the vascular cambium. So youngest secondary xylem occur um, outside vascular, just inside the vascular cambium. This one, not outside. Okay, just here it is just outside the vascular cambium. Outside of the vascular cambium or outer face, it is not the xylem, it is the phloem. So this cannot be the answer. Just inside cork cambium, no, cork cambium does not produce secondary xylem. Cork cambium produce cork and bark portion, that is secondary cortex. Okay, and this this one is just inside the secondary cortex. No, inside secondary cortex it is not, just inside vascular cambium, inner to the, just on the inner side towards the center. Next question, age of tree is calculated by its height, girth, number of branches and number of annual rings. So age of the tree is determined by the annual rings, or it is also called growth rings. Is it? As many, because one ring is produced every year. So as many growth rings or as many annual rings, that is the age of the tree, that many years of age. This is this thing, that determination of the age of tree. This one is known as dendrochronology. Okay. So next thing, next question. Let us see here. Here is one question, that is the phelogen and phylem respectively denote cork and cork and cork, the secondary cortex, and cork and secondary cortex. So what is the synonyms of phelogen and phylem? Phelogen is cork cambium and phylem is the cork. So what is cork cambium? This is alternate name or synonym is phelogen. Zen means which generate, that is produced, okay, which produces. This is a this generate. So that's why it is the cambium. Cambium produce new tissue cell. So this is gen. So cork cambium, and this one produce cork. Cork is phylem, and secondary cortex on the inner side. Secondary cortex is phylloderm. Okay, so this one phylogen come first, so cork cambium, and that you have to tick this one in sequence. Okay, what is the correct sequence here, and similar sequence you have to maintain. Next one, here is one diagram. Right, you can see in this diagram that where is the phylogen, phyloderm, and cork, etc. See here, this is a section of the stem showing the secondary growth. So here you can see that this is the epidermis. All right, this epidermis has been broken here, and this one is a lenticell. Remember that lenticell, lenticell. This is the cork cambium. This layer, this two cell layer, you can see this one is cork cambium, and the cork cambium is producing cork on the outer side. This portion is the cork. The cells, you can see they are nicely arranged. Okay, just in seems to be in radial column. Okay, and this on the inner side, this is producing the parenchyma tissue, but they are thick walled cells, and this is the secondary cortex. All right, so cork produce outside, cork cambium produce outside cork and inside cortex, and this portion is showing that the vascular cambium. See here, this is the vascular cambium layer, this portion. All right, this vascular cambium. So this vascular cambium produce outside secondary phloem. This portion is secondary phloem. This cells, you can see these are the crushed primary phloem due to the continuous pressure. pressure by this growing secondary phloem. This primary phloem, which is usually little smaller in quantity and soft tissue in compared to the secondary, so they are crushed usually. And on the inner side, it has produced the secondary xylem. This is the portion of the secondary xylem. These big holes you can see. These big holes are the vessels. Okay, metaxylem vessels. So that's why vessels had a very wide lumen. Then only they can conduct water very nicely. So these big holes that appears in the section, these are the metaxylem vessels of the secondary xylem. So this portion is the secondary xylem. Primary xylem is here. You can say primary xylem. This portion is primary xylem. This is the pith, bit light colored, and parenchymatous cells. Here the portions are dark. This is a dark condition is due to that they have the thick walled cell, because here most of the cells are tracheids and vessels, all are thick walled. So this portion is dark. So this is secondary xylem, and here you can see these lines. Okay, these are made of parenchyma cells. They are arranged radially in the secondary xylem as well in the secondary phloem, secondary xylem and secondary phloem. So these are called secondary medullary rays. This is secondary medullary rays. Okay, the secondary medullary rays, they conduct water, short distance water conduction they can carry out in a radial way, means from center to the periphery or periphery to the center. In the radial manner they can conduct water. So this and this one, which you can see right from the center to this, going up to the secondary cortex, this is the primary medullary rays. So secondary medullary rays and primary medullary rays. So this is come to the next. Okay. Okay, come here. Next question is, specialized epidermal cells surrounding the guard cells are called. A special epidermal cell around the guard cells. Here is one diagram you can see. Okay, these are the diagram of photographs of the stomata. So here you can see this special epidermal cells surrounding the guard cells are called what? Around the around the guard cell. These two are the guard cells, and around the guard cell, see here, one, two, three, four. Four epidermal cells are there. They are encircling the guard cell, and these cells are known as subsidiary cells. So our answer is here, the subsidiary cells. Specialized epidermal cells surrounding the guard cells are called subsidiary cells. Okay, these are all are the modification of epidermal cells. This was asked in NEET 1 2016. All the questions that I am giving here, solving, these are all asked in one or the other that pre-medical exams. Okay, next one is question: the common bottle cork is a product of what? This is bottle cork. Bottle cork, you know, that wooden cork for the wooden bottle stopper, wooden one, is it? Those are slightly spongy, and those that is the bottle cork, and the bottle cork is actually, it is dermatogen, product of what? Phallogen or xylem or vascular cambium. This one is product of, cork is a product of, this is actually from the cork tissue. Cork is a product of cork cambium, and cork cambium is phallogen. So this one, bottle cork, is a product of phallogen, and this phallogen give rise to cork. This is obtained from the from gymnosperm tree. Okay, next one is companion cells are closely associated with. Say this question was the AIPMT, All India Pre-Medical Test 2012 prelim. Earlier there was an exam that twice, AIPMT exam is twice. One is preliminary and the next one is main. So next question is companion cells are closely associated with. This is also AIPMT preliminary exam 2012. So two questions from this anatomy. This is companion cells are associated with. This is companion cells are component of the phloem tissue. Okay, phloem tissue. So phloem tissue, this is companion cells are associated with sieve tube elements. So sieve elements. That's why they forms the company of the sieve tube, closely associated. Next one, This is also from, next question also is from AIPMT prelim 2012. So many question from anatomy. The closed vascular bundles lack. What is there? What is absent from the closed vascular bundle? The closed vascular bundle does not contain cambium. So closed, in the closed, cambium absent, that is vascular cambium is absent, and in the open, the vascular cambium is present. Is it? Next question. As compared to a dicot root, a monocot root has, this is also AIPMT 2012 prelim. Sometime we don't know in which set of question paper or which year how many question will be asked from one unit. Okay, so here so many questions from anatomy, and in the same year in 2012 prelim, that as compared to dicot root, monocot root has more abundant secondary xylem, is it? Many xylem bundles, inconspicuous annual ring, relatively thicker periderm. No, they have this question more or less we have solved yesterday also, that they have many xylem bundle. That is the polyarch condition. Remember, monocot root has many xylem bundle, polyarch condition. And what else monocot root has? They have large pith also large, and many vascular bundles. Next question. This is AIPMT 2014. See, you are given a fairly old piece of dicot stem. One piece of dicot stem and a dicot root. Which of the following anatomical structure will you use to distinguish between them? One has been given the stem and one is root. So how does the stem and root differ? What is the difference between the stem and root in terms of the vascular bundles? In the root it is a radial vascular bundle, and in a stem it is the conjoint vascular bundle. Is it? But here it is fairly old stem. All right. So when it is fairly old stem, then there has been given dicot, it is called. So in the fairly old stem, the secondary growth has taken place. Okay. So you cannot decide what type of vascular bundle it is. So here another character of the root and stem is this root is exarch. Protoxylem is outside, and in stem it is endarch. protoxylem is on the inner side. So this protoxylem and protoxylem, they are actually primary. These are the primary xylem, is it? Primary xylem two type, protoxylem and metaxylem. So here it is the position of the protoxylem that will help us to determine or identify the root and stem. So here it is, the answer is our protoxylem. Neither the secondary xylem nor the secondary phloem. With this we cannot decide that which one, because when the secondary growth takes place, after the secondary growth, the root and stem, it is almost similar, because there is always xylem is produced on the inner side, phloem on the outer side. So they, by metaxylem they will become similar, but their position of the protoxylem will decide that which one is a root and which one is a stem. Next question. The tracheids differ from the trachary elements. Okay. Here, this one also, of course, a question I forgot to note that in some, I think, AIPMT, this question was asked. But here, in this question, little bit correction it should be there. This one should not be trachary element. This should be trachea. Trachea, or that is vessels. All right. Say tracheids and vessel differ in which way? Having Casparian strips, being imperforate, lacking nucleus, being lignified. Say tracheids and vessels both are lignified. They don't have nucleus because when mature, both are dead. All right. Casparian strips are not found in xylem. It is characteristics of endodermis. So this one, tracheids and vessels differ. Tracheids differ from trachary element being imperforate. Say what happened actually, this in the vessels are vessels are tube that is produced by joining or placing cells end to end, and their end wall, this one is, this is lost, means a big hole is there. Either it has a big hole or it has very large holes, several large holes. This is called the perforation or the perforation plate. So this vessels element, they are perforated. Okay, perforated vessel elements. Their end wall has many holes, perforated, and the tracheids, they don't have this. Tracheids are tracheids are they are the cells, and they have holes at certain places at the end also, but they are not the tube-like structure, they are single cell. So here whatever is given, they from all these four, the possible answer is this one being imperforate. Okay, there is no perforation. And this one, why this I told that in this question, this trachea element should have not written, because the tracheids and vessels are both together is called the tracheary element. Elements are tracheids and vessel together is called the tracheary element. So that's why this question should not be like this. In its place, it should have been trachea or vessels. Okay. Anyway, we have to find out from here. We have to know what the question says. Next one, read the different components from A to D. See here, A, B, C, D. Different structures are there in the list given below, and tell the correct order of the component with reference to their arrangement from outer side to inner side of a woody dicot stem. In a stem, from outside to inside, that is from the periphery towards the center. Okay, periphery to center. What is the sequence? Here it is secondary cortex, wood, secondary phloem, and phloem. So in a stem, this is after the secondary growth. So what will be the sequence of this structure? Which one is uh, just extremely outside at the outermost, and which is the innermost? Secondary cortex, wood, secondary phloem, phloem. See here, let us see this diagram again. See in this, if we see from this is again the secondary growth in a stem, it is showing outside from the periphery to the center. If we move, what is there? First, it is coming cork. Cork means it is phloem, is it? Then cork cambium, phelogen. Then coming the secondary cortex, that is the phyloderm. Okay. After that, we are getting the primary, of course, primary phloem, then the secondary phloem, then vascular cambium. After that, secondary xylem, that is wood, and then the primary xylem. Is it? So the sequence from outside to inside, it is, that is cork, cork cambium, then secondary cortex, then it will come the phloem, primary phloem, then it is secondary phloem, then this is the vascular cambium. After that, the secondary xylem, then primary xylem, and at the center is pith. So this will be the sequence in a mature dicot stem where the secondary growth has been taken place in this way from outer to the inner. So that's why here our answer will be, see here, first on the outside phylum, is it? Out of these four, first will be phylum. Next, this is outer side, and say if this is, we are going to inner side. After phylum, then will come the secondary cortex. Secondary cortex, after that it will be phloem tissue. Secondary phloem, and on the inner it will be wood, that is the xylem. So what will be our sequence? Sequence is, first is D. So it is D, then A, after this C, and then it is B. DACB. So which one is the DACB? So this option 2 is the correct answer. This was also in the AIPMT 2015. Okay, next question. A specialized epidermal cell surrounding the guard cell, AIPMT 2016. This question we have already done. Okay, this has been repeated. This is the specialized epidermal cell. Okay, this is subsidiary cell. Okay, next question. Cortex is the region found between. This is the NEET second 2016. Cortex. So what is the portion of the cortex in a stem? Say this is epidermis, and on the inner side, say this is endodermis, and inner to the endodermis there is layer called the pericycle, and the ground tissue here, it is the tissue in between epidermis and pericycle. It is from here to here. So in this portion, in the cortex, actually hypodermis, general cortex, and endodermis. Like it, the outer boundary is epidermis, inner boundary is endodermis. So the tissue between the pericycle and here endodermis and vascular bundle, epidermis and stele. Say this will be our answer. Epidermis and stele. What is stele? Stele is that is pericycle, vascular bundles, pith, and medullary rays. This portion is called still. So still start from this pericycle. So pericycle, after that there is vascular bundles. Still is that column, central column, which consists mainly of the vascular bundle and surrounded by pericycle. Okay, so the tissue in between epidermis and the still is the cortex. So our answer here is epidermis and still. Identify the wrong statement in the context of heartwood. This is a NEET 2017 question. Incorrect statement. First statement is organic compounds are deposited in it, in the heartwood. It is highly durable. This statement is very correct. That's why heartwood is also called duramen. I have told. Uh, highly durable, it is good. It conduct water and mineral efficiently. This statement is wrong for the heartwood, because when it is heartwood, that heartwood lumens are blocked. That is the inner cavity of the vessels. Okay, they are blocked. Blocked by gums, resin, tannin, and the tyloses. Okay, so these things, this heartwood is blocked. As heartwood is blocked, they cannot carry out the conduction of water and minerals. Instead, due to this blockage, this heartwood become very strong, more strong. They have thicker cell wall. So they provide only mechanical strength. Physiologically, it is inert. That is the no physiological function, that the conduction of water is not taking place through this. Conduction of water takes place by sapwood. Okay, so this statement is wrong in context of heartwood. Then another statement is it comprises dead elements with highly lignified wall. This is true. This it is highly durable. This is true. There is organic compound deposited in it. Say these are the, as I told, the gum, resins, and other different chemicals are deposited within the vessels. So these three statement A, number 1, number 2, and 4 are correct, but number 3 statement is wrong with heartwood. So our answer is number 3 statement, because wrong statement has to be marked. Next question. The vascular cambium normally give rise to, say this is NEET 17 again. The vascular cambium normally give rise to what? Vascular cambium give rise to the secondary phloem and secondary xylem. So here options given: phylodon, no; primary phloem, no; secondary xylem, it produces secondary xylem; peridot, no. So out of these four options, it is only secondary xylem is produced by vascular cambium. Next question. This is from Jeepmar 2017. In a woody dicotyledonous tree, which of the following parts will mainly consist of primary tissue? In the plant, where we will get mainly the primary tissue. Primary tissues are, that is, primary tissues are there which are produced by the apical meristem and intercalary meristem. This apical meristem and intercalary meristem, they give rise to primary permanent tissue. Okay, and secondary tissue is produced by lateral meristem. Lateral meristem, that is cambium, vascular cambium and cork cambium, they produce secondary tissue. Okay, so here the question is, in a woody dicotyledonous tree, which of the following parts will mainly consist of primary tissues? Where we will get? We will get mainly, here the options are stem and root. In general, it has been given because in the woody dicotyledonous tree, there is secondary growth also. So when the secondary growth takes place, a major part of the plant organ contains secondary tissues, secondary permanent tissues. Primary permanent tissues are very less in those organs of the root and stem after the secondary growth. Okay, so this cannot be the answer, stem and root. All parts. No, this also cannot be the answer. Shoot tip and root tip. This is the answer. That is, in the shoot tip and root tip, there is, at the shoot tip, there is apical meristem. Root tip also contain apical meristem. So they produce the primary permanent tissues. Right? So in a woody dicotyledonous tree, the primary tissue mainly contain in the shoot tip and root tip. The flower, fruit and leaves, here also the secondary, some of the secondary growth also takes place. Okay. Next question, the pear fruit. Okay, pear fruits are gritty due to the presence of what? Trachid vessels, fibers and sclerids. This is, say, this one is question from Jammu Kashmir CT. Jammu Kashmir CT. So these are the important question asked in different state universities also. So here that when you eat pear fruit, this is unpleasant due to presence of some things which come in between our teeth, no, while munching this fleshy part of this fruit. So this gritty condition is due to presence of sclerids. Sclerids are sclerenchyma tissue, and among the sclerids there is fiber, and the other one is sclerenchyma tissue. One is fiber and one is sclerids. Sclerids are short, small, of various shapes and sizes. Okay, so these cells are present. They are present in isolation, not in group. Okay, fibers are always in group. Fibers, sclerenchyma fibers are found in groups, in mass, but the sclerids they are found isolated. And these sclerid, different types of sclerids are there. Due to this presence of this, that gritty condition is there, and these are also known as a stone cell. Okay, these are stone cells. So due to this presence, we find unpleasant taste of the pears. This is also found in the pulps of guava, sapota, okay, and some other fruits it is found. And due to presence of this sclerids is lignified cells, okay, and if plenty of this we eat, then indigestion takes place, because these cells are not easily digested, and so we may have the stomach problem, that is indigestion problem. So here is the next question, that a simple living permanent tissue absent in root. Simple living permanent tissue absent in root. This was asked in Maharashtra CET in 2014. Okay, there are options: collenchyma, chlorenchyma, parenchyma, sclerenchyma. Out of these three are living. Sclerenchyma is dead. So our answer will be from this, in between these three. So among these three, so which one? It is the living. See, chlorenchyma, of course, chlorenchyma is found in uh, Parenchyma is nothing but it is a parenchyma tissue. Parenchyma in root, stem, everywhere it is found. The collenchyma is a tissue which is absent in root. Collenchyma is not found in root. Collenchyma is found in stem, particularly in the dicot stem. So our answer is collenchyma. Next question. Vascular cambial ring of dicot stem is? Vascular cambial ring of a dicot stem is primary in origin, secondary in origin, embryonic, partly primary and partly secondary in origin. Okay, so this is vascular cambium is partly primary, partly secondary. The intra fascicular cambium. Cambium is primary. Okay, and interfascicular cambium. Cambium, this interfascicular cambium that originate from the medullary raised cells. So permanent tissues it originate, and that's why it is secondary in origin. Secondary in origin. So intrafascicular primary and interfascicular secondary. Interfascicular and intrafascicular, say this is if two vascular bundles, here is cambium, here is cambium. This cambium are intrafascicular. Okay, this is intrafascicular. But in between these two vascular bundles, the cambium is produced from the primary permanent tissue. So this portion is secondary in origin. This is interfascicular and this one is secondary in origin. So partly primary, partly secondary. Cork cambium is completely secondary in origin. Cork cambium, this is secondary in origin. Next question. This question was asked in Kerala 2008. Next question also is from the Kerala 2011. In dicotyledonous root, the initiation of lateral root takes place. See, the lateral roots originate from pericycle layer. From this is endogenous. That's why we call the lateral root are endogenous in origin, in its origin. Lateral roots, but the lateral branches of the stem, they are exogenous in origin. Right? So here our, this is answer is number 5 here. Say in some of the earlier the state medical colleges and other places, there were 5 options. Okay, this one also had one more options. I kept here only 4. So whatever it is, our answer is this one, pericycle cells. This originate. Okay, so this is all about the anatomy portion. Anatomy is completed. Now you can do practice as more from your practice book.